right, so our last lesson of the unit, yay! When we estimate values between two given data points on a graph of a linear relation, I can't read the rest here, hold on. We estimate interpolation. So interpolation is given the data that's presented, we can read within the dots, so basically are the points. So example 1, using interpolation to solve problems. This graph shows the distance traveled by Bobby's family on a trip from Calgary to Moose Jaw. How long did it take for his family to travel 320 kilometers? So as you can see on the graph here, the distance is 320 kilometers. Do you see? There's 320 kilometers. If I read going down, you can see that it took him 4 hours. That is interpolation. Make sure you put your units there. So again, what I did was I looked up where 320 kilometers are, hit the line, looked up where that coordinate is. You can see the coordinate is 4,320. So basically, they were giving me the 320 part of it, and then I look up what the x value of that is. Okay, let's try this one. Use the graph to find the following values. The cost of 15 liters of fuel. So do you see liters of fuel is the x-axis. So 15 would be between 10 and 20. So that would be that right there, that coordinate. And so then I would read across. And when I read across, I see that, well, it's not $15. It would be less than that. So it looks like $13 to me. And I would give you a little bit of a leeway of how it is. But $15 would not be correct. $10 would not be correct. It would have to be, because it's halfway between 10 and $15. It's actually a little bit more than that. So $12.50 would be the halfway point, and I know it's more than $12.50. So you got to take your ruler and read across. Okay, so now I'm going to use a different color pen here. The quantity of fuel that can be purchased for $10. So $10 is my cost. Here's my $10. As you can see, it's past that. So it's going to be more than 10 liters. So you might say 11 liters. You might say 12 liters. I'm going to go with 12 liters. When we extend a graph of a linear relation to estimate the values that lie beyond the given data points, beyond the graph, we use extrapolation. So here's an example. Using extrapolation to solve problems. On the family trip from Calgary to Moose Jaw, Bobby wants to predict how long it'll take to travel 640 kilometers. Okay, so here's the thing. This whole snapshot that we have only goes up to 400. So we can extend the data point. So what would the next tick be on the graph? If this is 80, 160, 240, 320, 400, it would be, yeah, you'd go up by 80. So this is 480. 480 would be right there. Then another 80 would be 560. And then another 80 would be the 640. So that means it has to be 3 ticks past this. So here's 1 tick, here's 2 ticks, here's 3 ticks. So what I'm going to do is I'm going to now extend this line. So first off, I'm going to take my ruler and extend this line. So extend the line. Okay, make sure it's right on the money there. And then what you have to do is, I'm going to take a different color line, if I can get it. Different color line. Let's see if I can do red. And what I'm going to do is, I'm going to go across from 640, so I can read it. And then I'm going to go down with my ruler so I can read this. So now I'm going to take and see what I got here. So does everybody see this is 2, 4, 6, and it looks like 8 hours. So that's extrapolation, where you have to actually read off the graph to predict what's going to happen in the future, or something that you haven't actually got data for. Sometimes they give you a part of a graph and then you just have to extend the line. Again, you need to use a ruler, so make sure you're using a ruler to do this. So as you can see, the cost of 30 liters of fuel, the line does not go far enough, so we're going to take our line and extend. Okay, now I can read 30 liters up. It hits the line right there, and then we're going to go across. So you can see it's not exactly $25, it's more than $25. Let's say $26. And I would probably accept $27, but I wouldn't accept 25 because it's not on the 25 line, and a little bit more is getting a little bit too extreme. That's why you have to use your ruler so that this can be way more precise. Okay, so, and other things, we're going to use this information to answer the questions. And so you got to really pay attention. Are they giving you the X or are they giving you the Y? So easy questions if you understand what they're asking. Hard questions if you're not paying attention. Okay, so first things first, I'm going to extend this line. Okay. And I'm going to extend it this way. So that would be my first thing, so that I can read everything. Okay? So now that I have that, now I'm going to answer the questions. What is the value of X when Y is 1? So now what I'm going to do is I'm going to look at where Y is 1. That's when Y is 1. What's my X value? 0. Do you understand where I got that from? Okay, what is the value of Y when X is 1? I'm going to use a different color. X is 1 here, right there. So I read to get that line. There's my point. What is my point? It's 1, 2. So Y is 2. Because that was in my original data given, that would be interpolation. Now we're going to do, and I just see that my notes say A twice, so I'm going to change that to a D. What is the value of X when Y is 4? So Y is 4 right here. So I'm going to read across. Do you see there? That comes down. So what is that right there? That would be 3. And last, what is the value of Y when X is negative 4? X is negative 4 here. So read. And so what's that value right there? Negative 3.